All right, here we go. We're continuing with section 8.2, dealing with right triangles. So let's stick another right triangle on here. Now look, today's lesson, at least the first half of this, should be very, very familiar to you because we've dealt with it before. We used this a bunch of times in the last chapter. You'll be very familiar. Watch this. If I call this A, I call this B, and I call this C. We haven't really, I don't think we've discussed this too much, but this is a leg and this is a leg of a right triangle. I think we might have mentioned that some time ago. I don't think we have since we started this chapter. But this right here is a leg and this right here is a leg. And I don't think we've officially introduced this. Okay, you probably know what it is already, but what is this word? Right, it's a hypotenuse. Alright, so that's the hypotenuse of the right triangle. How do you know it's the hypotenuse? Because it's opposite what? The right angle. And what's something that you probably already know about the hypotenuse as far as comparing this to the lengths of the other two sides? The hypotenuse is always the what? It's always the longest side, okay? The hypotenuse is always the longest side. Now, some people say this. Some people say, oh, I know it's the hypotenuse because it's the longest side. No. All right, because you could have a triangle that has a longest side that's not a right triangle. Would you agree? So that doesn't mean that the longest side is always the hypotenuse. The hypotenuse only exists when you have a right triangle, and it has to be opposite the right angle. Now, we do know that the hypotenuse is the longest side, but just because you have the longest side of any triangle does not make it the hypotenuse. Everybody got that? Okay. Now, what do you think I've been talking about when I say we've been doing this before, and we did it in the last chapter, and it's a right triangle? Pythagorean Theorem. Let's write that down. Pythagorean Theorem. Now, Hannah, in Korea, do you guys say Pythagorean Theorem, or do you have your own word for that, or how would you say? Do you pronounce it like? Do you pronounce it Pythagorean, or do you pronounce it like a Korean version of it? How do you say it? Say it again. Pythagoras. Does that sound right? Oh, look at that. Okay, go ahead. Pythagorean is how we say it.
Who made that?
Pythagoras.
Yeah.
Yep.
So
how do you say his name? Yeah, it's a guy's name. Pythagoras. Okay. That means theorem or rule or something, that last thing you said? Okay, gotcha. I don't think so. Alright, his name's Pythagoras. It's one of these guys walked around. You know how like Aristotle and Plato and, you know, all those guys had one name, right? Alright, so Pythagoras is one of those guys that walk around. I read a little bit about him. He's one of those guys. You know how Jesus had disciples and followed him around and stuff? Jesus wasn't the only guy that had disciples. Did you know that? Back in the day, they didn't have schools. They didn't have, you know, Jerusalem Elementary or Jerusalem High School. Okay, the way that they were taught was they would actually kind of follow people around. It was kind of like more of a mentorship kind of a thing. And that's what these disciples were following Jesus. They were his mentor. And these other guys had guys following around, like Aristotle and Plato. They would teach them about math, they'd teach them about philosophy of life and all that kind of stuff. And I believe, if I read correctly, that Pythagoras was one of those guys. He taught all kinds of stuff, not just math, but he taught all kinds of things, and people would follow him around. And he would teach people. He was kind of a teacher and a theologian and a philosopher, mathematician, scientist, all that kind of stuff. All right, so look up Pythagoras one time, and I forget what the years are. I've looked him up before. I forget what it is, and I don't really care at this point. Let's do the Pythagorean Theorem. Do we know what it is? Now you probably say it. How do you say it? A squared plus b squared equals c squared. I'm going to write it just slightly different. I'm going to put the c first, if you don't mind. And there's a reason for that. I'm going to write it c squared equals a squared plus b squared. Same thing, isn't it? But there is a particular reason why I'm writing it that way. Now notice that the c always has to be the hypotenuse. You follow me? The a and the b always have to be the what? The legs. The legs of the right triangle. Okay? So if I know it's a right triangle, I can take the hypotenuse, square it, and it equals the sum of the squares of the other two legs. if I had time, I might try to find a clip of this. I probably should have done it before, but actually, if you watch The Wizard of Oz, you ever watch The Wizard of Oz, and who gets the brain? The Scarecrow or something like that? Scarecrow gets the brain. When he gets real smart, if you watch it, he actually does his version. I don't think it's a correct version if you listen to what he says. It's a little bit off. It's not quite exactly, but you know how he acts real smart. You guys watch Wizard of Oz and he gets the brain. He says da 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 da. He says the sum of the squares of the sides of a right triangle. Da, da, da. I forget exactly what he says, but he messes up a little bit. But that's what he does. He basically tries to repeat the Pythagorean Theorem. Isn't that interesting? Okay, so that was way back. That was like 1939 or something. Or actually, I don't know if it was that far back. I don't know when it was. But anyway. So there you go. Watch. That's a right triangle. Now, we've done stuff before, and we're running out of time. I'd really love to do an example. I tell you what, I think we can fit in an example. Let's do a quick example. All right, so let's get rid of this. Let's get rid of this. I'll do a real basic example. Let's go a different color. Let's say this is, I don't know, 5, and this is just 7, all right? And we want to find what C is equal to. Everybody with me? So let's do it real quick. You should be able to do this. So that means C squared is equal to 5 squared plus 7 squared. So C squared equals 25 plus 49. And C squared equals, what's that, 74? Let's see. 2 goes into 74 how many times? 37. Right? 37 doesn't go. So you can't simplify that. So if you take the square root, it's just the square root is 74. And then you would just leave your answer just like that. Simple as that. No big deal, right? Everybody, right? You guys are fine with that because you've worked with Pythagorean Theorem quite a bit in the past. All right, let's show you one thing that you may not have known until maybe today. Hopefully. Watch this. If C, I said, was the longest side of that right triangle, wasn't it? The hypotenuse. What if you just had any sides? Okay, they give you 3 sides. Let's give you, let's just make up some. Let's say 3, let's say 7, and let's say, that's 10. 10's got to be bigger than that. Let's say 9. All right, is that all right? So if I had sides 3, 7, and 9. Yes, Alyssa.
Just do 3 squared plus 7 squared.
That's not what I'm getting at. I'm not really asking. I'm just saying, let's say we have, I'm going to show you something different. If you have 3 sides, does that make a triangle, by the way? Remember we had that little rule?
Oh, yeah.
If you take the 2 smaller ones, it has to be bigger than the third one. Yeah, so that is a triangle. So test that first to see if it's a triangle. Now what I can do, I can test to see if it's a right triangle or not. So now what I can do, the C is the longest side. Now I don't know this is a right triangle, okay? But let's test to see if it is. So I can put a 9 in for C and put a 3 in for A and a 7 in for B. Work it out. If they equal each other, then guess what? It is a right triangle. If they don't equal each other, guess what? It's not a right triangle. But I can go a step further. You guys still with me? Watch this. If I took the longest side, C squared, and if it came out to be larger than the sum of the squares of the other 2 sides. Hear what I said? It's a lot of words, but I said sum means add the squares of the other 2 sides. You see it? If this was larger than this, okay, it's going to be an obtuse triangle. All right. Now remember, if they were equal, what kind of triangle would it have been?
Right.
It would have been a right triangle. Agreed? If it's equal, it's a right. If it's greater than, it's obtuse. So, yeah, what do you think? If C squared was what? Less than A squared plus B squared, guess what kind of a triangle that would be? That would be an acute triangle. All right, so let's do this one right here, and let's see what kind of triangle it is. This is why I put the C first. Do you understand that? Because it's easier to compare it when the C's out in front. So which one would the C actually be?
9.
It'd be the 9. C is always the largest one. So I take the largest side, 9, square it. I'm not going to put an equals here. All right, just leave it blank. And then put a 3 squared plus a 7 squared. Let's see what we get. What's 9 squared? Okay, this is 9 and 49. What's that? 58? Is that right?
It's obtuse.
Yeah. So 81 is what? Greater than this thing right here. So you're right. This thing is obtuse. So that's an obtuse triangle. That's the kind of stuff they're going to ask you. some of this stuff. I mean, some of the things they're going to do this. They're going to say, you know, find the missing side using Pythagorean theorem. And then you're going to have another section of problems that ask you, is it a right, is it obtuse, or is it acute? Let me give you some problems to do, and then you can go on your merry way. Okay, section 8.2, and we're doing pages 546, 547, and it's 9 to 29.
If I told you have to do 25 note cards in this class,
There it is, right there. Enjoy it. Enjoy right triangles. Enjoy Pythagorean theorem.